Alright, so this video is about integration using linear substitution. So here's a integral question. The integral of a function times a function raised to the power of n with respect to x. Now, we're going to do linear substitution here. Now, as long as that g of x is a linear equation, so that means it's in the form mx plus c, and it's raised to some power as long as the power is not 0. We can solve this even if f of x and g of x, even if one's not the derivative of the other. So we're going to use similar techniques to what we've used in the previous one, which was the reverse chain rule question. But we're not going to be as reliant on the fact that the derivative appears in the integrand, which is what we were doing last time. So we're going to do an example of this. You can see how it works. Alright, so here's our example here. The integral of x, that's a function, times a linear function, x minus 2, so mx, m is 1, c is negative 2, raised to a non-zero power, 5 on 2, with respect to x. So we can use linear substitution here because we have a linear function raised to some non-zero power. Now, so let's do our substitution. We can let u equal x minus 2. So that's going to give us something like x u to the power of 5 on 2 with respect to x. That's a big problem because we've got x's and u's inside of this integral. We can't really work in that way. So we want to sort of re-look at f of x in terms of u. So thinking about how we can do this, we can change this x. So we said that u is equal to x minus 2. So that means that x is equal to u plus 2. So I can take that u plus 2 and I can put it in here. So that's going to be u plus 2 times u to the 5 on 2. And then we don't really want to do like a dx on the end either, because we're integrating with respect to u. So using this same bit of information here, let u equal x minus 2, we can say that a new piece of information here. So this doesn't really follow from that. Let's use something different. Alright, so using that same information, we can say the derivative of u with respect to x equals, now the derivative of u, x minus 2, is just 1. And it follows that dx equals du. So it looks like we can just do a straight swap here because our dx comes to the front. We've got du that replaces dx. Right, so now we have the integral of u plus 2 times u to the 5 on 2. Let's see what we're going to do next. So at the moment we've got like a function multiplied by a function, and integrating that's really, really difficult. But we can just use, because this is u to the 5 on 2, with or without brackets, we don't really need these brackets. It's u to the 5 on 2 times u times 2. So we can actually expand this just using our distributive law. So we're going to have u to the 7 on 2 plus 2u to the 5 on 2. Now that 7 on 2 comes from u to the 1 times u to the 5 on 2 is the same as u to the 1 plus 5 on 2, which will be 7 on 2, with respect to u. So now we're really just integrating to two of these. So it's going to be u to the 9 on 2 over 9 on 2, which is going to be the same as times 2 over 9, plus u to the 7 on 2 divided by 7 on 2, which is going to be the same as multiplied by 2 on 7, multiplied by 2 on 7, so it's 2 times 2, which is 4, and 7 here. So now we have the integral of that is 2u to the 9 on 2 over 9 plus 4u to the 7 on 2 over 7 plus c. Alright, nearly there because now we just need to muck around with the u. So we'll just move this all up here. So we've got 2u to the 9 on 2 over 9 plus 4u to the 7 on 2 over 7 plus c. Let's put x minus 2 back in here. So it's 2/9 times x minus 2 to the power of 9 over 2 plus 4 x minus 2 to the power of 7 over 2 over 7. Oh, actually, let's not do that. Let's just do 4/7. 4/7 x minus 2 to 7 over 2. Now, depending on how you've gone with factorising in the past, you should be able to see that there's a 2 over 9 bracket x minus 2 to the 9 on 2 plus 4 over 7 x minus 2 to the 7 on 2. These have a common factor, and so we just look for the one with the lowest power, so 7 on 2. So they've both got a common factor of x minus 2, 7. So x minus 2, 7 on 2. They've also both got a common factor of 2. So if I bring a 2 out of both of these, I can just stick it there. And what we're left with is x minus 2, just to the power of 1, because 7 over 2 times 1 is going to make 9 over 2. X minus 2 over 9, and then that gives me, this is just going to be like 2 over 7. Alright, so it's 2 times x minus 2, 7 over 2, x minus 2 over 9 plus 2 over 7. I can group these now. Make sure I'm not going to fall off the screen. It's going to be like 63. That's going to be 7x. So I'm just multiplying everything here by 7. So 7x minus 14 plus, I've got to multiply everything here by 9. So it's 18. Alright, and we'll just finish that off. 2 bracket. Why am I doing it here? Let's do it up here. 2 bracket x minus 2 to the 7 on 2 bracket 7x plus 4 over 63. And just don't forget, I've been forgetting the whole way through, just don't forget your plus c's on the end. Alright, so it's pretty straightforward, and then you've got a bunch of that factorising mess that you did in Maths B. Give it a crack. Going on 2.